Hello, Math 142 student. This is the second part of Chapter 6.1. Continue with analyzing standard normal z. In part 1, we did finding the probability of z greater than a value, less than a value, or in between two values. In the second part, we would do the reverse. That is, do the cutoff, find the cutoff in case we were given a top area or bottom area, or actually, I should say top percentage or bottom percentage, or in other words, left area or right area. So if I am given that, even I'm given some area either on the left side or on the right side, what happened is there is a command that the graphing calculator has implemented that would let us find the cutoff. But it is actually the inverse of normal CDF. And in normal CDF, um, they always expect a right area. By default, they already expect a right area. So when you want to find the cutoff, the way to do is you always try to give the right area. So the inverse normal typical command will be inverse normal your left percentage or left area 0,1. If you actually have the right area, you can actually produce the left area so that inverse normal can function by subtracting the right area. So you can say, I have this right area, but I will subtract 100% subtract this side, it will be this side. So you would do inverse normal 1 minus right percent 0,1. And for TI-84, they implemented a tail in the command where you can say just give the right percentage and do right tail. So left percent, you just give left percent. If you have right percent, you do 1 minus right percent. So that's the idea. So let's do an example. The typical example would be I have a lot of z. What is the z-score that is the cutoff for the top 8%? And what is the bottom, the top 8%? And what is the cutoff for the bottom 7% of C? So they're talking about, you're actually asking for two things. Top 8% are the C that is really high, right? Top C is in the middle. A lot of them are in the middle because the bell curve go like this. The top percent are these. There is a cutoff, and beyond this, these are all of this percentage or the probability of percentage is 8%. So that means area is 0.08 top, right? Right side, right area. So to find this cutoff, we would use inverse normal, but because we have the right area, we have to do the 1 minus for non-TI-80 for color. 1 minus 0.08, 0,1. Okay, so use the calculator. Turn on. Second verb. Inverse. 1 minus 0.08, 0,1, because we're talking about z. And then the answer is 1.41. 1.41. So let's go back to write down our answer. So we go to 1.41 because it's in the top area. But what about bottom 7%? So let's draw the bell curve. Whenever you find any of these cutoff, you should draw the bell curve. Bottom value of z, of course, on the left side, we don't know what it is, so be all these. And we don't know what this is, but the percentage, meaning the area, is 7%. So I will shade this area to be 0.07 because the bottom, right? Bottom is this one. So that is 0.07%. So what's the command? That's very good because this is an easier command because inverse normal always look for left area. So you just give them left area, which is 0.07, 0,1. So in the calculator, very straightforward. Second verb, inverse norm. We don't need to do 1 minus, it's just 0.07, right? Because that's the left area. And that's negative 1.48. So go back and do negative 1.48. So the z obviously is on the negative side because it's below 0. Okay, because in a c score curve, oops, the the middle is zeros and it is below 0, so it's negative. That makes sense. The second goal, or actually the third goal, of 6.1 is to find something called a critical value. So now this is a new term that we just learned. Usually in statistics, a critical value is a number where on one side it is very normal, you're not surprised, it's not significant, but on the other side it's either significantly low or high. And in this particular case, we are trying to find a cutoff for significantly high and non-significant. So if I draw a picture of the Z number line, so they're a high number, right? So these are zeros. These are in the zero, they are likely to happen by chance because the bell curve is like that. So these are quite high, significantly high. But what is the cutoff so that these are all unlikely? Now it depends on what is unlikely, right? So by default, unlikely is had a probability of what 0.05. So we say, well, probability is area, so this must be 0.05 for default. But later on in starting in chapter 7, we have this case where sometimes we actually want to control what we want to define as unlikely, because an unlikely probability will determine what value is being critical. Critical means after this cutoff, at the two end of this cutoff, on one side of it is non-significant. I expect to see it. It can occur by chance, but these are very unlikely. So we define a symbol called alpha that is a variable of probability of unlikely. Default is 0.05, but we can assign it as 0.1, 0.01, sometimes as low as 0.005. Maybe you can do it at 0.0001 also. So this probability of unlikely, we actually have a symbol alpha, which is a Greek letter, a letter A of the Greek letter, and in statistic term, it's called significant level. Significant level. We'll be using a lot of it again in chapter 8. So remember this name, significant level, means probability of unlikely. Symbol is alpha. So if you assign another name for it, then all of a sudden the graph would not be 0.05. So let's erase it. By default, it's 0.05, right? But it would be alpha actually, right? So it would be anything that you want to define. And if you want 0.05, you just tell people my alpha is 0.05. So I should write alpha here instead of 0.05. And we want to find the cutoff. And this cutoff, we give it a name, is a z value, but it's related to alpha on the right side. So what's the best way? Just write alpha on the lower right side of z, kind of lower. Now just remember, this does not mean z equal to alpha. It's actually a z cutoff. It should be like close to 1 point something or 2. Okay, so it's not 0 point something. So how do I find C alpha? It means that I have a right tail. So to do right tail cutoff, I do inverse normal 1 minus alpha 0, comma 1. And for TI-84, you do not need to do 1 minus, you do alpha and right tail. Okay, so the two questions that I want to work on is find Z 0, 0.5. Okay, so the first one, this means this is my default critical value when alpha is 0.05. Alpha is probability of unlikely. That means I have a bell curve of Z with see 0 here. And then I know there's a number. This is critical value Z alpha, and this is 0.05. The right side is 0.05. And what is this? Right? So obviously to do that, I do inverse normal, right? I am not finding area. I actually have the area. So I would say inverse normal. And I have right tail. I have to do some subtracting, 0.050, comma 1. And except if you are TI-84 color, you can just put it in, but remember to do right tail for TI-84 color. So put in a calculator. No, that's not the calculator here. So I do second ver. Oh, it's turned off. Second ver. Inverse normal. 1 minus 0.05 because that's the right area. And then I press enter. It's 1.645. 1.645. Put it down. You go to 1.645. So if you are 1.645 times the standard deviation from the mean, you're actually unlikely. I'm gonna skip this. So if I want to find z 0.005, I do the same thing. So just that my right area is 0.005. This just show that you can actually select whatever alpha that you want. This alpha is really low. The last one that we want to do is called percentile. So percentile is a notation of P of K. If you want to find a percentile cutoff, that means this number is higher than K% of all data. So meaning if you draw a number, a normal curve on here, so you have all this number, some of them are higher than, so for example, this Z, and this is 0. This Z, what is this Z? So that is higher than all these, right? So these are below Z. So these are below Z by, and the percentage of all these Z is 9K%. That means I have a left tail of K%. So of course, to find the this particular cutoff, I'll do inverse normal because I know left area. So you just put K% here in decimal, 0.1, run inverse norm, and then you're done. And for 84 color, you do left tail because percentile means you have a left percent of K%. So let's do an example, P99 for Z. So you would say, I have a lot of Z that it can happen by chance, but a lot of them are 0. What is this particular Z? It must be a big number that is higher than 99% of all. So that means this is, starting from here, this is 0.99. The left side area is 0.99. How do I find it? Inverse normal, because you have the area already. Inverse norm. It is on the left, so I just put 0.99, 0.1. And for TI-84 color, you do left. You do left tail, and that would take care of it. So clear the screen. Second, inverse norm again. We don't need to do minus 0.99, 0.1. And so this number 2.33 is higher than 99% of all three. 2.33. And that's the second part of 6.2, second part of 6.1 for Math 142.